Yeah, just to maybe start our discussion, John, could you provide an overview of the Proportionaire QBX proportional electro-pneumatic pressure regulator, how it works and maybe what benefits it offers?
Yeah, so the QBX is it's kind of a mouthful, proportional electro-pneumatic pressure regulator. And what that really means is it's a closed loop pressure regulator. It provides very accurate, highly repeatable pressure control. It works the same as most modern pressure regulators nowadays. In fact, they're all based off of the design that our founder, Dan Cook, patented about 40 years ago. And it's pretty much you got your two pressure valves or two control valves and a pressure sensor and then a little circuit board that does everything. So what happens is you send the regulator a command saying, hey, I want to go to this pressure. It looks at the pressure sensor and it says maybe, hey, we're down here, we're not enough. So it lets in more air. It opens the inlet control valve until they're the same. Or the opposite, maybe like, hey, I want pressure to be here. The actual pressure is up here. So it reads the pressure sensor, says, oh, you're too high. Let's open the exhaust valve and bring it down to hit right there. The QEX in particular goes from full vacuum to 175 PSI, but a big thing with us is we're highly customizable. So if you have something specific for an application that you need something that's 0 to 100 PSI, we got you covered. If you need it to be 32.8 to 73.6 PSI, whatever, we can accomplish all that for you too with the QBX.
Hmm. Okay. So maybe what makes this particular technology different or unique compared to other pressure regulators that might be in the market?
So there's a few things. Some of them is just the generic electronic versus traditional pressure regulators. The electronic part helps there with that control system. But in addition to just the control system, the traditional pressure regulators, the output kind of changes as the inlet pressure changes, the output will. So that pressure sensor kind of overcomes that part there. Some of the original electronic pressure regulators were actually called I to Ps. So you'd send it a current, and I to P is current to pressure, but it wasn't actually pressure. It was actually just more of position of a valve inside of it, which kind of gives you the same problem. If the pressure going into the regulator changes and you're just controlling how open or closed the valve is, then the outlet pressure is going to change. In addition to that, the I to Ps, the internals were not as robust as they are now. So as the I to P actually moved around, the valve inside of it would move and the output pressure would change. So you couldn't put it like on the end of a robot or something because every time you swung the robot, your pressure would be changing. So that's some of the biggest things that control system inside the circuit board inside the QBX and the pressure sensor overcomes those, which we don't have. Our products don't have the same issue as the I to Ps did. They're kind of all the modern regulators are built different with different components. But if something downstream of the system does that, where it's changing as part of the process changes or as something moves around, the QBX will be monitoring that and make adjustments. The unique thing is our accuracy, repeatability, and build quality. That's what kind of sets the QBX apart from other proportional electronic pressure regulators. Highly, highly accurate and repeatable. We do have, sometimes we kind of hit the edge of physics. So we have another one, the QPV, for the super, super sensitive ones, but the QBX fits the most demanding applications.
Mhm. Could you maybe go into what some of the applications would be that this technology is best suited for then?
Some of them, it's hard to say what it's the most best suited for.
Yeah.
We control process variables, and because that's such a wide variety of things, it's hard to say what's the most benefit. It's like asking,
Mhm.
oh, what's the best benefit for a screw?
Yeah.
It really depends on what you're using it for.
Mhm.
The benefits really vary wildly. Um, that being said, most commonly we're used in automation. We actually really helped totally revolutionize a few industries, mainly is manufacturing, just generic semiconductor, medical, automotive labs. And the one that's really fun to talk about is themed attractions. Got some stuff with those. some specific examples would be tire curing and tire uniformity. So they use our products to control the steam temperature in these big, huge autoclaves where they're curing a whole bunch of tires at once. Or uniformity, they pretty much spin the tire and they have as the tire's spinning this way, they have a little sensor right there pushing up against the tire. So if there's any kind of disuniformity, if it's got a lump here or a spike there or something, it detects it and they'll know either to rework it or scrap it, depending on how far down the line it is. Catheter leak testing or burst testing. Catheters are kind of important to make sure that they're going to
Mhm.
be where they are. So some of our customers use one of our products to test up to 1,000 PSI
Yeah.
on those. Uh, Cataract removal surgery, after they're done doing all the things, like I said, the QBX goes down to vacuum, so it actually acts as a little vacuum, sucking out all the cataract leftovers. I'm not a medical type
Yeah.
person, so I let someone else deal with that when I
Yeah.
saw a video of it once. I was like, no, thank you.
Yeah.
And then I mentioned semiconductors. We're pretty much everything to do with the silicone from, they call it growing it, but from forming it up, slicing it, spraying the different chemicals on it, every step of the way in there. Those are some of the big ones we've seen a lot of success with.
Well, thank you so much for taking the time to speak with me today and provide some insight into uh, proportionaires, electro-pneumatic pressure regulators.